Okay, let's look at a different example. Let's say maybe we want to try, I don't know, something like this. Okay, once again, I used a difference last time. Let's use this up. Doesn't really matter. We want to solve this. Okay, it's a sum that's set equal to 0. That doesn't help me. But if I had a product equal to 0, set equal to 0, then I'd be able to use that rule. So it would be nice if I could write this as a product. Now, I want to refresh your memory for a moment about a specific rule that we had. When you have A times B plus C, you can distribute the A over to both terms. And keep in mind, these don't have to be variables. They could be numbers. They could be anything. In a rule like this, A could just represent sort of any combination of numbers and variables together, or its own, all sorts of things, let's just say. So this is called the distributive rule. Most of you are familiar with it, that you can multiply both of these by the A to get this. But remember, we can go in two directions here. So if you see a sum of two terms, and each term has something in common, each term is a product involving the same thing, well, maybe we can go back and use this rule to simplify. So let's see what I have here. I have x squared, which is really x times x. And you can write it like this at any time. You don't have to. I'm just doing this for this first example. Normally I wouldn't. But notice that this is an x times x, and this is a 2 times x, or x times 2. It doesn't matter what the order is here. So each of these terms has an x in it. So what I could do is, using this rule, I could rewrite it. And if I don't believe the rule, maybe I think I get scared, I might have made a mistake, I could always go back and check my work by taking x times x, well, that is x squared, and then x times 2, that is 2x. You can always sort of reverse your steps if you're unsure of yourself. Okay, so now I have a product set to 0. That means x equals 0, or x plus 2 equals 0. Well, if x plus 2 is equal to 0, x is equal to minus 2, and this is my solution. I know there can be no other solutions because the only way this product could be 0 is if one of these two terms is 0. So this is it. I also know that these are both solutions because if either of these terms is 0, I get 0. But maybe you're nervous, maybe you think we made a mistake. Well, one thing you can always do, if you think you might have made a mistake, is plug these back in. For example, if I plug the 0 back in, I get 0 squared plus 2 times 0, which is 0. And if I plug the negative 2 in, I get negative 2 squared plus 2 times minus 2 equals 0. Well, that's 4. That's minus 4. 4 plus negative 4, 0. So we didn't make any mistakes. Now, some of you might not want to check your work ever because you're like, you want to get the problem done as fast as possible. And I understand getting things done as fast as possible is good. But there's also a lot of good in checking, especially if you're not sure of yourself, because it only takes a moment to check. It's a lot faster to check your work in this course and in your upcoming courses, usually, than it is to do your work. So if it only takes you like a second to do 4 minus 4, but it takes you a minute to do the problem, spending that second is probably a good idea. Okay, well, some final thoughts on this. We had this equation. We wanted to know when this left side equals the right side. We were able to regroup using the distributive law. When we regroup, we call these two things the factors of the original polynomial, and hence we have the name for this section, which we are going to call factoring. So sort of the art of regrouping things so that we can use multiplication. But let's look at some more examples.